Hello everyone and welcome back to another video provided by SVSU's Online Tutoring. My name is Joel and today we'll be finishing up with our topic on graphs of exponential functions. And in our last video I wanted to point something out before we move on, and that was if we take a look at the graphs here after we filled out our table, the thing that I wanted to point out was that both the black and red line have the same horizontal asymptote. Asymptote. There's a P there. Yep. So both the red and black line both have the same horizontal asymptote, but the blue line, its horizontal asymptote is at what looks like to be negative. I think it should be what, negative 1, right? I know it's not really exactly drawn to scale, but you can see that it would actually end up being at negative 1. So when we're doing those types of shifts, some of the characteristics change. Vertical shifts cause different changes with the asymptote, and both shifts cause different y-intercepts. So the blue line has an intercept at y equals 0, but the red line has an intercept at y equal 2. Whereas the black line, our regular function, our regular exponential function, just had a y-intercept at y equal to 1, which is what you would expect for any of them. So those are the things that you have to keep in mind when doing shifts. How the characteristics of each line give you different results. And now what I want to look at are shifts in the or not shifts, but reflections, another kind of transformation. So if we have, switch my colors here, if we have f of x equal to 3 to the x, okay, we've seen this one before, but we can also have g of x equal to negative 3 to the x, and we can also have h of x, which is 3 to the negative x. So again, let's go through and create our table. So I have f of x right here, g of x, and h of x. Negative 2, negative 1, 0, 1, 2. So f of x is quite simple. I can just go ahead and fill that one out. H of x is also quite simple. It'll just be f of x, but in the reversed order. So 2, oh, I'm sorry, that should not be a 2. It should be a 9. 9, right there. Put that guy back there. Yeah, 9, 3, 9, 3, 1, 1/3, 1/9. And then g of x, however, it'll be a lot like f of x, but now we have that negative sign. So all the values in our output just become negative. Negative 1, negative 3, and negative 9. So let's take a look and see how each of these lines compare to each other on a graph. So let's go down here, and I'll draw my axes. Let's make it straight. Straight-ish, I guess. And so we have, can do negative 3 there, negative 6, and then negative 9, negative 3, negative 6, and negative 9. And we have negative 1, negative 2, 1, and 2. So f of x, right, when x is negative 2, our value is 1/9. So that's just barely above the x-axis. When it's negative 1, it's 1/3. Again, barely above the x-axis. When it's 0, it's 1. And when it's 1, it's 3. And when it's 2, it is 9. And that line looks like this. So something like that. And I'll do h of x. So h of x, when that's equal to -2, or when x is equal to -2, we have an output of 9. And when it's -1, it's 3. And when it's 0, it's 1. And when it's 1, it's 1/3. And when it's 2, it's 1/9. And so that comes in from this end and goes down and through the y-intercept right there. It begins to plateau. It doesn't pass the x-axis, so just be careful. It only looks squiggly because my handwriting is terrible and I can't connect the dots very well. But take note that both lines pass through the same y-intercept right here, and that they both share the same horizontal asymptote, which is the x-axis. But if we take a look at g of x, all the values are negative, right? So we should expect f of x, but flipped or reflected across the x-axis. So at -2 we have -1/9. At 1 we have -1/3, and at 1 we have, or at 0 we have -1, and when x is equal to 1 we have -3, and when x is equal to 2 we have -9. So that graph comes in, and I'm going to redraw that, make it look a little better. Comes in just like that. So you can see g of x equal to -3x is a reflection about the x-axis, and f of x is right here. And g of x is a reflection about the y-axis. So those are the three types of graphs you can get when dealing with reflections. That does it for this video. In the next one, we'll talk about the natural exponential function, and what we'll discuss there is introducing e as our base. So you've probably seen e before. I may have thrown it in one of my videos, but now we're going to be dealing with it as our base for exponential functions. Okay, see you next time.